All right, what's up, everybody? So this video is intended to introduce you to our chi-square test. There are two different tests that we're going to learn about within this. It's called a one-way test or a two-way test. Throughout this presentation, I'm going to introduce you to other names that you'll see used to represent each of these. As you know how I like to do, making sure you know how what it is that we're covering now builds on things we've covered previously. So we are building specifically on nominal and ordinal levels of measurement. Just as a quick kind of explanation as to why that is, for our t-test and our ANOVA test, both of those analyses require you to incorporate a dependent variable that uses a scale level of measurement or interval ratio level of measurement. The reason being, we are calculating means, the averages, and comparing them between groups. For the chi-square test, we're not using variables, interval ratio or scale variables. We are using nominal and ordinal variables to look for relationships between variables. We're also going to build a little bit on what we learned in Module 2 regarding frequencies and expanding a little bit on degrees of freedom specific to the chi-square. So chi-square is what's called a non-parametric test. So we were introduced to t-statistic in Module 7 when learning about hypothesis testing. We were also introduced to the f-statistic when learning about ANOVA, analysis of variance. Both t-tests and ANOVA require what's called normality, which is just another way of describing needing really large samples to be an effective test, and interval level data for our dependent variable. If these requirements cannot be met, we must use chi-square or a non-parametric statistic. So here is the notation for chi-square. It is written as x squared. The x should be italicized. This is particularly relevant when you are writing your results for reporting on your analyses within SPSS. We'll learn a little bit about what's called the observed frequency, which is one component of being able to determine significance within your chi-square test, which observed frequency represents the actual or true frequency from the sample. And we'll also learn a little bit about what's called the expected frequency, the anticipated frequency representative of the null hypothesis. So finding expected frequencies, the way that we calculate expected frequencies is going to look different based on which test we are conducting within chi-square. There isn't a formula that you would use to calculate the observed frequency because that is the thing that we are observing happening. We've already collected data on it. That is what we've observed. For calculating the expected frequency for a one-way chi-square, you would add up all the frequencies in your test and divide by the total number of groups. And so here's the formula. Fe equals the sum of Fo divided by K. We were first introduced to K in the previous module for ANOVA. We learned that K represents your number of groups. For calculating two-way chi-square, you would multiply together the column and row marginal totals for a particular cell and divide the product by n. Now, I'll expand on what row and column marginal totals are when we begin talking about the two-way chi-square. But the formula is expected frequency is calculated by row marginal total multiplied by the column marginal total divided by n.